Okay, and we're live to the recording. Good evening. It's the 28th of December in Dallas, and we're having our regular Robot Builders Night virtual. We'll do what we normally do, go around the table, discuss things related to robotics or adjacent things or whatever in the world crosses our mind as often surfaces, but generally related to things robot-y or musical, as Mr. Anderson is showing a symbol right now in his camera.
Oh, that's a gong.
That is a very fine looking thing. But the musical qualities, I think there's some technical.
No, I think that's a Harold and Murray timeout sound maker. I think that's what that is.
That could be. Oh, now we have it. We have progressed. We have found the way when things go on a little too long, when somebody makes a statement that's not according to community standards, which we have loosely defined on an ad hoc basis.
See, I'll probably be thrown out before the evening is over.
Well, we can mute you if you get out of control. So you have free reign. Oh my goodness. I love it.
You can use that when we get off topic.
So for the next four of us, Harold, Pat, Paul, and Carl, I guess we've been warned, haven't we? We've been warned. We know what's waiting for us. On point it is. Okay. With that, I should yield the floor. We're in a good babbling mode, but this is between the holidays, so that's awesome, right? So Harold, have at it, my friend. What's been going on in your world? Did Santa bring some amazing new toys for you?
Thank you for the lead-in for the Santa thing. I believe one of these Tuesday nights, somebody accused me of being an uber geek, making, my geekiness make all the rest of everybody looks normal, which I don't truly believe that in this crew. But saying that, Santa was nice to me. Most of it was the Disney World trip. So we had stocking stuffers. And I don't know, she didn't really stuff this in the stocking, but it showed up in the stocking that just so that everybody else can see. Let me do a little switcheroonie here. This is what I got in my stocking. Anybody beat that?
Bob Ross Chia Pet.
Anybody beat that? I'm just saying.
So he basically grows a happy little cloud around his head.
Grows a happy little cloud on his head, yes. I'll be firing that up and probably taking that to work before too long.
Murray, do you know who Bob Ross is?
The painter?
Yes.
Yeah.
Yeah, of course. How could you not know who Bob Ross is?
He's got a Twitch channel. There's always a few hundred people watching him. Almost.
Well, he's dead though, isn't he?
Yeah,
he's
dead. Died in like 1992. This is somebody in his estate is running the channel, and that kind of thing. So
I went to art school. You can't. It's kind of like.
Well, this is Harold's Christmas present. It's a chia pet that grows hair.
Yes. I don't have any hair though, so I have some, but not enough. But
cool. Actually, I kind of just want Harold to just get a wig.
Dude, I could probably do that. That was what I got for Christmas. On the little bit more serious point, I've been fooling around in Twitch, doing a couple of things, and this is what I got run into. I'm my Zemo, which is my ExoMy rover, and somebody named it for me. I want to upgrade that with ROS 2, and so I can do I ran into a bunch of problems with used to be called in the Windows world DLL hell. Basically versions of Python, versions of this, versions of all these various different things. None of them I get to play one another. And this thing just does it. Go get that thing. Yeah, I'm running something that's 2 revisions older, and I'd have to backport it, and I wasn't going to do all that. So I started in the last couple of streams figuring out how am I going to track this stuff. And it turns out that GitHub has a pretty cool tracking mechanism. So what you're seeing on the screen right now is the repo for my Zemo. And I can post that up to the repo if anybody cares, but that's not the real point at the moment. You see, I've got currently 24 open issues just because I was lining them out. But then how do you make sense of them and how do you work with them? Well, GitHub has these things called projects. Now, these projects here have been around for a long, long time, but they've got a new version of the project, and this is what I've been playing with. So what I've decided to do was I decided to put a nomenclature to it. So I've got my repo : and then the in the agile terms, we call these epics, or the feature set that we care about that we're going to do. Oh, hey, my baby just showed up. I gotta level my baby. Hold on.
Rolling with your homies. That's exactly what you're doing.
Oh, okay.
Is that a real baby or like one of those?
That's like my lovely wife who puts up with me through all the crazy stuff I do.
Well, let's give her a round of applause. I must say.
Absolutely. My goodness. Mrs. Harold does a wonderful job.
She's appreciating that mightily.
Harold's wife gets a gold star.
Yeah, if anyone on this call could get a good gold star, it's Harold's wife.
So, so the nomenclature I decided on is I'll have the projects they work more like epics as opposed to multiple project things. And there's a couple cool things about it. I can have an issue show up in 2 different projects if I want, and a few other things like that. But it just gives me a way to organize these things. For instance, that's my untitled project that I just made a thing and I haven't named it yet. But you see, I've got them all put up there. So if I go to one of those projects, which is be right. No, let's go to one of them. Yeah, let's go to one of these. One where I've done something. Set up gazebo. So I've got a couple of things right there, right? Create a model that I can use in the space, create a thing. You see these green circles means I've assigned it. So if I want to create another one, I'll make a happy face, just for example. And then now that's a new issue, but it's not assigned to anything. And I haven't gone through and fully set up the whole works, but I'm going to add a repository column here so I can show which repository it's assigned to. And so it's just a real fast thing. So figure out how to display gazebo. See all these things right here. I've got 24 of those. Even when I refresh, go back over here, I do that. Oh, I really want this because even though I set it underneath this project here, there you go.
Why don't you make that full screen?
Do what now?
Why don't you make that full screen so we can see it a little better?
Oh, I can actually zoom in for you.
And
it better?
you can pin his display to the screen,
Oh, I'm
Dave.
sorry. Yeah, pin in my display.
There we go.
But Harold, could you start off at the root level of the GitHub repo? Because I'm trying to understand.
Sure. So
I'm not
let's go
seeing
to
how
the
to
repo.
navigate to where you are.
Let's see. I got the repo where there's nothing in the repo now yet. I
Right.
just started building it
You
up.
got issues, pull
I
requests,
go to
actions, and
issues.
projects.
Now I'm going to issues, and you can see the issues I just made there. Make a happy face, and these are all the issues that I have assigned to this thing. Now I'm using the word issue as something to be done as opposed to a bug. And it can be bugs as well, but in this case, since we're just starting, I'm more of a task or more of a not necessarily a task, or more
Or a feature or a thing.
a thing that needs to be done. It's not. We got this thing where we have tasks that are parts of a story, right? These are more stories, and then tasks will come later out of them, and that kind of stuff. And then you have these things, what I'm calling epics, are a list of stories. These things. So
how did you get to projects though? Because I see.
so
five projects.
this gets a little bit of wonkiness on it. You can say new issue here, and that's fine. How do I get to projects? Is that I will come over to my see where I go to up here projects. This is a little bit wonky on the whole thing. And because this is beta, they default to the projects where I don't have any projects. This took me, I don't know, good 30 minutes of stream time to figure that out. One of my guys goes, what happens if you click on the beta version? Oh, there's all my stuff. Right. And that's how because this is beta. This is not, they're doing new things with it, and to actually edit one of those projects, it's pretty simple. Zemo sample for DPRG. If I could type. So there it is. And actually, it makes this real. See where it says object avoidance right there? I don't need, we're going to change it to something else, but let's make that right now. And then we want to make this is the only way I know to assign a repository right at the moment. Put on here, it should remember, but it doesn't. XMO. Yep, that's my repository. And now, since I assigned it that project, I got that Zemo object avoidance. I'll go back to the, if I just sit there and wait a little bit to refresh on its own, but you see where the object avoidance story is now in there. So
yeah, the new GitHub issue, or what you're calling a story.
Yeah.
But it's not a project per se.
No, it's not a project. The project is back over here. So if I'm in a project,
and that's what I can't figure out how to find the same screen.
Okay, I go underneath you got to go to your dashboard, or it's off your dashboard. So I go click on my name in the upper right hand corner and then select your projects. And then you can use the old current stuff, or you can click on the projects itself.
Okay, that's why I can't, because it's your projects, not my projects.
Yeah.
All right.
And then you can set all of these. In this case, for this sample here, I can get to go into it and I get to set the settings. You can make it public or private. And that's about all you can do right now. Maybe pick a name for it. You can set some status on it. What options you have to do done and everything for the various projects and stuff you're working on. I'm still exploring about how all this works. But I thought it was cool enough that I wanted to share. And we've been going on it, but you see how now I can go to my projects. I can go look at my stuff, and like I say, I'm working on get Zemo moving, and I've got all the stuff that are issues that either somebody has submitted and we've assigned to this project, or or where I've created it in this project and assigned it to the repository. Issues in the repository, and I got it all one thing about things I care about that I'm looking at. I got Trello boards. I got half a dozen different things. I've got post-it notes out the wazoo, all that kind of stuff. And I was looking for a way where I could get all of this sort of into one tool. Like in my day job, I'm using Azure DevOps or Jira, Atlassian Jira. Both of those are sort of a one-stop sort of shop where I can go to that one application and one thing, and everything kind of meshes together to work. They have interfaces with GitHub and GitLab and a few other things in the Atlassian side. And of course, Azure DevOps has all of their their source code controller, and they have a Git interface and all that kind of stuff as well. So it's kind of real nice so that I can reference all these things in different places, and they all come into one place. And I was looking for something that was free and then I could use going forward, and at least play with it and introduce it to my stream to see how they like it and see how they're playing with it, how they like it and what's going on. And it also gives a way for all these open source projects or these various different crazy things that I get in the middle of. Maybe I make it a project. And in fact, I've got 2 things I need to do coming up. I need to write a new talk about Mr. Bighead and get my printer going for that conference down in Round Rock presentation I get to go to. And I'll probably use some project stuff on that as well to make sure I cover all those things. I was really looking more for a thing where I could go one place and look for a status of a bunch of stuff, what was open, what was closed, and not have to. There was a real nice interface going from Trello back into GitHub, but that turns out it's a 14-day free trial. And since I'm not really making any money on it, I don't want to really pay money for something that I can get for free one way. And then if I was actually making money on something, maybe I'd do that. But in this case, no, I'm not going to do that. I'm kind of cheap, money's a big deal. I'd rather spend it on robot parts and electronics and Arduinos and Raspberry Pis than
Cool.
that sort of thing. Anyway, it's about what I got to show, and hopefully that helps somebody or gives you an idea or whatever. I'm still figuring it out, but that's what I've been playing on.
Thank you, Harold. That is just fantastic. That's like an agile project management kind of tool. That's like super helpful.
Yeah, you could. I think you're going to have to wedge the agile stuff at it, with all the terminology because they don't call it that. But at least it gives you some functionality to be able to put that all into one place. Because I don't know if you noticed, I got 54 repositories out there. Some of them get issues, some of them don't. That kind of stuff. Keeping track of all that kind of stuff becomes a mess, and it becomes too much work.
And this is so closely tied to the repository.
Yeah,
I mean,
and
in
the
my
other,
day
the
job,
other
we
cool
have to
thing-
bounce between Jira and Bitbucket, and
Yeah. The other cool thing that I kind of mentioned, but I didn't really show here because I don't have a good example. Let's say I've got a team and I got a project going in this situation. I can attach that project to multiple repositories and get issues from all of those repositories showing up in one place. That could be pretty powerful if you have that situation. Currently, I kind of don't, but could be there.
oh, cool.
Harold, did I miss something possibly? Are you able to move the issues up and down as like priority?
In this case, I wanted to do that, and I tried to do that. And there's another view out there that I can ask, and I can say this view is a board view, and I didn't show that. I think I can move those.
Wow, they're really trying to compete with Jira.
Yeah, they really are. They really are. And when I say new view, this is a board view, and you can do columns, and you can search for stuff and rename it. And there's a whole bunch of junk I ain't even got in the middle of yet. I haven't.
That looks really good.
What now?
Very helpful. Looks
Yeah.
really good.
Hopefully, hopefully it helps somebody. And if you use it, great. If you don't, great. I figured I'd share.
Cool. Well, thank you.
You're welcome.
I think next in line we had Pat. Did you have some questions? Did I gather?
Yeah, I have just something I'm thinking about. Short-term memory on a robot. And I'll see if I can present a window. So it can show up maybe a little bigger. I don't know.
Looks good.
And in the middle, actually, I'll share a different window because it's a little bigger in the other window, I think. Where to go? A little right. That a little bigger?
Yes.
A little more colorful?
Very nice.
Okay, so this is something I'm thinking of doing in Python, developing grid map. And the idea for the grid map is not to represent the whole world, but to represent a very short-term view of what the robot sees. Whereas right now I've got the blue R in the middle would be the robot's location. And I've got a bunch of zeros, which would mean essentially there's nothing there. And then I have some ones. So the ones are, let's say each digit represents about 10 centimeters area. So about, let's say 35 centimeters away at a 30-degree angle or so, I have a 1, which would represent maybe my wall following sensor saying that, hey, there's a wall at 35 centimeters. And I'm in a corner. So basically sort of the ones represent, hey, you're coming up to a corner and that's what's there. So what I'm looking to do is how can I rotate this array as the robot makes a turn?
Question, is the robot always in the center of the array, or does it move around within the array?
So the robot is always in the center of the array.
And is
Okay.
forward like pointing up in a way.
So up would be pointing forward.
So the top surface of the R is normal to forward.
Yes. So essentially the ones all in front of the robot would be my sonar sensors and saying that basically there's something in front of it.
And
Why
you want
do
to
you
do
need to rotate the array? Because you could just move the array to left or right rather than moving it up and down to represent left and right, east-west motion.
Yeah, so if my robot were to turn 90 degrees, so now the ones that were in front of it would essentially become to the left side of the robot.
Correct.
And so that's what I'm wondering. Have you ever seen a function or something that I can use without getting into a ROS function to sort of track that?
Sure I understand.
I've
Given the current situation that you have displayed here, if the robot was then to move forward 10 centimeters, what we'd have is the R would still be in the same place, but the ones would all move down toward the bottom one row.
Yeah.
Is
So
that correct?
yeah.
So,
So the
the
idea I get
robot
is that
stationary and the walls move around.
yeah.
So
I
there is
think-
something called matrix math, and I don't know if it's available in Python, but that would do what you're wanting, is just move the matrix around. But I would submit that it's more likely you'll have better luck keeping track of where the robot's pointing and keeping all the ones and zeros in the same place.
Yeah, so that's
Moving
the
the
other
R.
thing I was thinking of is that I may have better luck with exactly as you say.
That's my
And
plan for mine. I haven't implemented anything yet.
And I think the one problem you're going to run into is that any kind of graph transformation like this, if let's say your robot rotated 5 degrees, because of the very limited resolution of the graph, you're going to have nodes in the graph that will basically not fit into a particular XY coordinate on that transformed graph. And you won't be able, if you had a really, really high resolution, you could transform them into positions that maybe you have to give up on certain positions and slot them into the next one. But when you've got a really low resolution graph like that, even a small transform of 1 degrees or 5 degrees, you're going to lose a lot of the information.
Yeah, and that's what I was thinking. So I didn't have an idea on how I was going to do this, but I think the idea may be to just keep track of my robot pose and populate my graph accordingly.
You seem to be alluding to some kind of temporal aspect to the objects, that they remember where they are in some fashion.
Yeah, so it's just a short-term memory. So you come across a doorway on one side or the other. So you can sort of identify or remember that there was a door there.
Is the problem you're trying to solve that the sensors may not be picking up objects all the time, but you want to remember what they saw?
Yeah, so if I see, I'm going down along the wall, the hallway, and I see a gap. I see the wall stops. So there's an opening. And I go a little further and I see the other side of the opening. Well, now I can analyze and say, hey, there's a 3-foot gap and you should be able to fit through there.
But
Pat,
at the moment you want to make that decision, you can't see the wall on the left side. Is that correct?
So you can't see the complete wall. You don't know that is it an opening? Is it a corner? You don't know.
Yeah, it's disappeared from your senses.
Yeah.
Pat, does your robot have a magnetometer on it?
It will.
Because I would suggest, if you could, just keep the map always facing, let's say, north, south, east, west, and basically transform. Because some of the stuff that I've seen from the MIT robot labs, that's the kind of thing they were doing, is they were just keeping the orientation of the map always the same and letting the robot move around within it.
Okay, so
Yeah.
that
I've seen
Yeah.
two versions of this kind of idea. One was non-temporal, no persistence, and it was it had the robot in the middle of the array, like you show there, and the map was updated every scan of the lidars, so that as the vehicle would turn 5, 10 degrees, whatever, then the ones would be populated in different squares, but within your kind of 10 centimeter resolution. So that was the no memory flavor with a vehicle centered obstacle map around it. And obviously, as the vehicle moved forward, then essentially rolled the rows downwards.
Yep.
But they were always populated from the current sensor readings. The other version I've seen is similar to what you have in the ROS Octomap, where you can decay where objects that were seen are populated with a probability, and so they can grow each time they are seen by a sensor. Their magnitude increases, and the magnitude can decrease when they're not seen. So that results in an effect that handles temporary obstacles. For example, if a kangaroo runs in front of your truck, then it will leave a kind of a trail behind it as the map population values from where it was fade into nothing, and the map values where it is to now are accelerated quickly to a high level. So those are
That's what I'm trying to allude to, is that so my robot would essentially, if I'm facing forward, would always see this area essentially, or pretty close to, let's say, this area.
yeah.
With this is what becomes in memory.
I've only really seen that in terms of a static map and not a vehicle centered map. And I think the reason why that is a static map allows you to overlay that kind of sensor driven obstacle on top of a priori obstacles, such as that there's some boundaries to the road, or there's a warehouse somewhere, or stuff like that. You just add the two together and you get a composite obstacle map in the world frame.
Okay, so I'm thinking part of my thinking is the same as you had said. If this would become something in the view, and it's the cat roaming across, so it goes, from there to there. Oops. And it would move across.
Yeah.
And so the next, a few scans later, it's disappeared.
Yeah.
Out of view. So it's no longer blocking the path. So rather than react to it, let's say, hey, right away I see something. Well, it's a little ways away. Let's delay an action. Hang on, it's gone. Just carry on with what you're doing.
Pat,
Yeah.
it seems like that that is going to require a lot of labor from the sensors to be accurate. That is to say, in your simulation here, or your example here, those points stay in place until, I guess, the next scan, right?
Until the next scan, yes.
Okay, so they don't, this is what I think Paul was referring to, they don't fade away over time or something like that. So if you have a bad reflection from your sonar, that will stay there until cleared by, I guess, moving to another position and getting a proper reflection.
Yeah, so
the little I've done with grid maps, I've basically built the map to require multiple sensor inputs before you declare that one of those 10 centimeter boxes has something in it. Require at least a few of them.
Yeah, so we could do that and say that So the first time I read it, it's a 1. That's the second time I read it, it's a 2. Third time I read it, it's a 3, and I'm going to call it something's there.
Yes. Yes. Now, if you do that, you also need some way to make those things fade away.
So as the robot rolls and the map goes down in direction, eventually it'll fade out of the grid.
I understand that. It's not clear to me exactly why you need a grid in that case. It
Okay.
seems like all you really need is the sensor returns.
And I don't understand, like, if you, I presume that this is based on LiDAR data, so spinning
No,
LiDAR, right?
it was going to be represented by ultrasonic readings. So
Okay,
where
but-
one ultrasonic sensor may cover a couple of grids, a couple of rays in the grid.
So you'll have how many ultrasonics around the perimeter facing outward?
So I've got 3 forward facing at an angle, and I've got 2 wall following at a 45 degree.
So
Pat,
just
I'm
like
not
you-
100% convinced that you actually need this to do what it is you're doing.
Yeah, I'm not sure either. It's
Because
just
it-
something I was thinking about.
It seems like that if you read this, if you're going to read the sensors and update the grid each cycle through your control loop, that really all you really are doing there is collecting the sensor information, and you don't really need to save that in a grid. Maybe I don't understand exactly how you intend to use it, but
Yeah,
you know, if there's an object that's 30 centimeters in front of you and you continue to drive toward it and it continues to decrease in distance, then eventually you're going to have to do something, stop or turn.
Yes.
But I'm not certain at that point. Let me rephrase this. The ways I've used a grid have been more like what Paul was describing, where there may not be a priori knowledge about what's out there, but the robot itself begins to gather that information. So every time it gets a hit on a particular grid item, its confidence that there's something there goes up. And as I say, you can have a way that those are also decayed, so they fade away if they're not getting hits. But in that case, basically the grid is the map and the robot moves around within the grid. So it doesn't really fit your definition of a short-term memory.
Yeah. So what I was alluding to is basically like a short-term planning. So do I make a left turn and try to go find the target at the door opening, or hang on, there's still nothing in front, so maybe we'll want to carry forward.
Pat, are you going to just be using for this experiment, you're just using one sensor, right?
I'm using, let's say, a total of 5 sensors.
Okay. Well, I've shown something before that is definitely for you should look into. It's on Instructables and it's under adapting mapping. If I'm going to present a little bit here, just to show you this stuff, and you can say whether or not it's something that you want to take a look at. Okay. It's going to take me a little bit to get it all together here. Okay. Let's see. The name of it is this. This is the name of the Instructable. Okay. And in this case, he's basically got one sensor, an infrared sensor here in the front. And he's doing an active mapping. You can look at this, there's a video on it somewhere in here where anyway, so the video will show you it going around different obstacles and stuff. One of the things that you run into is when you make a turn or make a decision, then your grid all has to rotate. I mean, the axes change. So if you can imagine, if you're looking at it as a robot and you turn 90 degrees for some reason, now from your robot, you're still looking forward, but in the world view, it's turned 90 degrees. And he has, this is actually based on a Society of Robots project, and this is their download index, and the one you're looking for, and I don't remember if it's the iRobot create Stompy or the create Wavefront. It's one of these two files in here that has some simple code to handle a grid. And he's only using, like I say, he's only using one sensor. If you add additional sensors, it's not too hard to use this as a starting point. So let's see if I've got, okay. All right, you can, here's some of the, if this is the code, I'm not sure if this is the exact file that you want, but it's one of the files that shows how he propagates a wavefront to figure out the best path in the particular map that he has. And somewhere in here, he talks about how to change the I think this is it. So here's where he's changing the directions of the robot. It's all kind of something. I'm just suggesting this as something to look at and see if it's of interest to you. And this is a file inside of the zip file that's on that index page that I showed you.
Can you post a link to that index page?
Yeah, I will.
Well, I'm not sure if this is going to help me or not. I was just looking at it as a tool to help decide what direction should the robot be going, as opposed to just following, let's say, a right-hand rule or as you're solving a problem.
Pat, another thing that might be useful along those same lines, the sonar have kind of a wide field of view, say 15 degrees. So if you get a hit 30 centimeters away, you don't really know where it is within that 15-degree field. But ignore that for a moment and just say, I'm going to make the simplifying assumption that it's in the middle of the field. So on my robots, when I read back that return from actually for any of those sensors, but particularly for the sonar, it returns not just the distance, but I also calculate the position in X and Y. So it's not just a point in a grid, but it's actually has its own grid coordinates associated with it. I do that because I know the robot's X and Y. I know the distance from the center of the robot to the detection, and I know the angle. And that's all that's needed to calculate. So the radar returns are not just a distance, but they include that XY location. And then you don't actually have to have them on a regular grid anymore. If that makes sense.
Okay. An XY location.
Yeah, you know the XY location of the robot. So I'm assuming you know that.
Yep.
And so if you have a sensor that's pointed off 15 degrees from the center and you get a return from 30 centimeters away, then that's just a right triangle, right? So you can calculate the actual XY from your known position. And
it's from my known position to that position that's blocked, essentially.
Yeah. And so, and in some ways, there's not a real reason to keep a record of where there isn't a detection. Because when you know where there are detections, by definition, you know where there aren't. It's everywhere that you didn't get one. But as I say, I'm having a hard time envisioning the algorithm that you're trying to develop, and it may actually, you should go ahead and try to make this happen and report back to us.
Yeah, so that's I was just curious to see is basically trying to detect what would be the best path towards a goal, with not knowing a complete map of your environment.
I think that's kind of like what Doug has been trying to do. Doug, are you here? Yes, Doug is here.
Yeah.
Is that not correct? To have kind of a local map that you carry around with you that changes all the time?
Yeah, with the idea that I'm not, Dave, I'm doing it more as a thought experiment, okay? Because what I'm wanting to do,
No, I meant on your own robots.
Yeah, well, that's one of the things I'm trying to accomplish. I don't, but it, the idea I was following is if you have a big grid, a big map, and you really, when you're looking at it from wherever your robot is, you can only see a very small portion of the map. And if you assume that that you're in a desert in the sense that you don't know where the walls are, you're going to find the walls when you get to them, but you don't know where they are. All right. So it's just really kind of, you want to just walk. You're just trying to map out your sensor, what your sensor sees. That's, what I'm saying? And you do have to, realize that, so you write things into your map, but if you keep going, the stuff behind you, you drop it off because you don't want to use up all the memory. Unless you want to, if it's an area like a room, which you definitely have enough memory to handle that in a grid of, I don't know, about 10 centimeters, 20 centimeters at least. You can map a room out in 20 centimeters and still have plenty of memory in most microprocessors if you want to go that way. But I'm, constructing a map where there's walls actually included in the map. It's not something that I generally want to do. It's too much work to accurately get it. But if I can do it as I'm if my sensors can process stuff as I'm going along, and if I quantify them in the squares I can go to or squares that I can't go to, it just can be simpler to understand. I mean, I know in your case, you look at your sensor and you see it 60 centimeters away, and you say, well, you're making a decision. If it's not within 20, I'm not going to worry about it, or whatever it is. And if it's in 10, I'm going to start turning, whatever rules that you've put in. But if you see something at 60 centimeters, you do know that everything between 0 and 60 is clean. There's nothing there.
Yep.
And if you only got a few sensors, you can just, where are you going to put them? You're going to probably put them at 90 and 45 and straight. All right.
So I've got one straight ahead. I've got, let's say, one at a 30-degree angle to the left, one at a 30-degree angle to the right.
Yeah.
For my ultrasonics. And then my time of flight infrared are at a 45-degree angle to the sides, left and right.
Okay. All right. And, you might consider putting the 90-degree one. I think David showed the value of that on one of his gold star runs that he did, where when you're turning, give me a second here. When you're turning, if you have an obstacle in front of you, as you turn away from it, somewhere your sensors are going to say, I don't have an obstacle in front of me. And that could easily be at 90 degrees. All right. Otherwise, if you have you're 90 degrees and they're still getting a reading on it, you have to make a decision on what you're going to do. Are you going to clear that 90 degrees, or are you going to go for the 45 degree that you have here and go off this way? How are you going to handle it?
That was the point of the short-term memory, is that as I rotated the robot, I would know that there's something at 90 degrees because it's still there in robot memory.
I think I know what Doug is describing, although those sensors actually point at 45 degrees, but I can use my hands. So you have this obstacle here and your front looking sensors see it. And so that begins to turn you. And when you get to a certain angle, the front can't see it anymore. So as far as they're concerned, you're clear. And if at that point you then said, okay, I can go back toward my target, well, you can't. There's something still in the way. You haven't cleared that. Now, one way we do that in the little robots is you just say, well, you put in a little bit of a ballistic delay there. Just says, even though I'm clear, I won't try to turn back for, another couple of seconds. But a better way to do that is to have a side-looking sensor that can actually see that. It says, okay, I can actually tell you that I can't turn back that way. There's an obstacle there, not until that side-looking sensor clears. In that case, though, it seems like, Pat, you could just take all of your sensors, maybe this is what you're doing, just make one array of them, and then you're going to refresh that each time you do another scan.
Exactly.
Rather than trying to keep the last scan to operate from.
Exactly. So I would
In that case, you don't have to rotate anything, because the whole thing rotates with you, right?
Yeah,
Yeah.
true.
And one of the other things, well, one of the things that I found that one of the things you want to avoid is, let's say I have a series of obstacles. I think we did this series of obstacles. What you don't want to do is turn this way on this one, and then when you get to the next thing, you turn back and you're back into this guy again, and you just keep ping-ponging back and forth between the two obstacles. So you have to decide, once you've made the decision to turn this way or this way, you keep that up until something triggers a clear. All right, now that clear could be, there's a couple of different ways. One is a leaky integrator. Otherwise, you keep turning. If I turn this way, I keep turning that way until the leaky integrator goes away. And that's just simply that if I get a signal here, I set some value to, say, 100. So the value is 100. All right, and every time I loop through, if it still sees that thing, it's 100. But when it stops seeing that thing, it starts counting down. Okay? And so it has to count down 100 before I'll reset what direction I'm turning into, so that I can next time make a decision to go the other way if I wanted to. But hopefully you can clear it. That's one way.
That's what I had meant when I said you could put in a ballistic delay. Doug is describing how you implement that.
Yeah.
But basically, it's just a timer that says you can't do, even though you think you're clear of the obstacle, you can't do anything for a little while.
Well, there was a little difference, Dave. Dave, I understand. I'm sorry. Why am I echoing? The ballistic delay is when you finished clearing, but this one is slightly different purpose. This is the one to keep you from ping-ponging. So you've got to keep turning in the same direction in case you hit another guy right after that. Otherwise, okay, you cleared the first sensor, you start turning. Well, you really have, if you think of your world as this guy, you've got to make a decision to go around the world this way or around the world this way. But it is possible that you got something out here that when you come in around here, you may want to change the direction. You may want to start going this way instead of reacting to this and going around and always going around the outside edge. So it's the same type of timer, but it's used for a different purpose. That was what I was trying to get.
I see your point. I actually, on my robots, I solved that problem in a slightly different way.
Well, like I said, there's many ways. Go ahead. I'd like to hear it.
You may remember I described in the talk that, when you get a left detect, you turn right. When you get a right detect, you turn left. What do you do when you get a center detect? It's not so obvious what to do. And the rule I use is if you get a center detect, you keep turning whatever way you're already turning. And that solves the problem that Doug was just describing.
Yeah, you got to go consistent.
So when
and if you think about it, when you walk around obstacles, that's the way you do it. I mean, you don't suddenly get halfway around the obstacle and decide to turn the other direction and walk the other way. You keep following the outside perimeter of the obstacle. Anyway,
well,
I don't know if that was helpful or not.
There is kind of the meta question, which Pat and I think David might have alluded to, which is sort of that whole it's kind of a, I think it's like a whole sub area of research that like there's a paper by Lisa Meaden, and it's under the rubric of adaptive robotic control. It's basically this whole idea of planning, and between no planning at all and having like complete planning, there's sort of like this short-term planning, and I think that's Pat maybe is trying to head towards that. It's like keeping a very small amount of information, just enough to make these short-term decisions, and I think they've called it adaptive design, or, and I'm not sure how to pronounce her name, but one of Rodney Brooks's students, I think her name is Maya Matarek or something like that. She's published a lot of papers, and she was publishing stuff under like robot learning, and this isn't in the machine learning category. This is more of like a behavior-based robot, the next stage of learning and this short-term learning. This is something I'm quite interested in, is how do you kind of go just beyond behavior-based robotics and add enough memory so that you can make a little bit longer-term decisions, like Pat's talking about. Like, I haven't seen the edge of the doorway yet, but maybe if I move another few inches forward, I might. And sort of it's kind of like in that middle ground.
Yeah, so the idea with it is exactly that. Is I've seen the first edge, I haven't seen the second edge, so I'm not sure if I'm supposed to turn right here to go through the doorway. The second one is I've reached inside a closet or under a desk where I could have a little bit of memory that I know that, hey, I'm in a cul-de-sac. And rather than try to bounce my way out of it, saying, okay, well, I know there's something on both sides of me and in front of me, so let's turn around and let's just carry on forward straight back for a while and get out of the cul-de-sac.
Yeah, if you look under adaptive robotic control, I think it's what it's called, and then also, like I said, Matarek, Maya or Maja, it's Maja, Matarek, and she's I think she might still be at MIT, but she's still an active robot researcher, and she's got papers on this as well under robotic learning, and because she comes under the tutelage of Rodney Brooks, she was kind of in that category of research. She's not into the machine learning and heavy duty AI pathlanding, but more in the how to add a little bit to a BBS system to get this next level of planning.
That's sort of exactly what I was thinking about. And
well, Lisa Meaden, it's Meeden, I think. Lisa Meaden is one of the names that pops up.
Okay, see if I can find
kind of like mid-90s research.
Okay, thanks. Gives me something to think about. It's not a short-term implementation. It's something I was thinking about farther out. Right now, I'm still trying to get from A to B, and I keep saying next week it'll be ready. Next week it'll be ready, and it's not.
I know that feeling.
Well, could it be next week?
It's possibly it'll be next week, but I was
Cool.
hoping it would be today. And Christmas has interfered with all my plans.
You know, there are worse things to have interfere with your plans.
Yeah,
Yeah,
well, sometimes
morning,
family
but-
is important.
Jaw surgery.
Oh,
Yeah, surgeries of all kinds,
Finger surgery.
family health things. It's all bad. Mud
Well,
in the
Family,
basement.
family was my priority for the last week.
I think we all get a pass for the family in the last week, and to some degree over the New Year's maybe. So,
That's it for me, guys. Thanks.
good question. Thanks, Pat. I think next we have in line Paul.
Yeah, so I've been working on building up Mobot with new electronics, and have made some significant progress, and I'd like to report on that. And do a little bit of a show and tell, and explain. I think the power system that I designed is quite sophisticated, so I'd like to share a bit on that. This falls under the category of what we were talking about last week, the integration projects. They're not really about robotics, but they're stuff you got to do to make it work. So without further ado, I hope that I can share my entire screen here. Okay, so Mobot, can you all see the
Video.
my screen and the video I'm sharing?
There, now it's bigger. Yep.
So Mobot comes with a battery box that's one of these with a fuse in it and some connectors to connect to the robot around the back. And these used to contain two 18 amp hour lead acid batteries producing 24 volts. And I'm replacing the lead acid batteries with lipos. So I have a lot more space to play with. And you can see the electronics box with a good amount, probably half of the electronics and all of the power system located in it. And so what I've been doing is building that up. And so what I've got is, can you all see my terminal windows here?
Yes.
So this right hand window is logged in. So the electronics box contains an RPi 4 that's connected with USB serial to the robot through which it issues motion commands. So that's a SSH window into the RPi. The RPi is sitting on my home network, and this is a window on my local laptop, XPS 15, that I'm running here. And so just to demonstrate that it works, I'll run a little bring up script that runs on the RPi. So I've put Ubuntu Mate on the RPi and loaded ROS, and it all seems to work pretty good. Don't worry about this process dying. The odometry code, I haven't gotten that working yet, but I don't need it to make the robot drive. So I've fired up the robot steering here, and so if we look at the robot and move it backwards with the robot steering.
Does this do carpets or just mowing?
I can actually start the blades. I found out how to do that, but it's only for mowing. So so that's just to show that it works and is drivable. And so I'd like to switch over now to I'll terminate these things and talk for just a moment about so I did an analysis of a use case analysis of the use cases I wanted to support. So I wanted to support removing the electronics pack from the robot and powering it from shore power and doing development on it with the battery optionally present, and removing it from the robot, powering it from the battery with no shore power and doing development. And then all working on the electronics pack in the robot. By working on the electronics pack, I mean developing software potentially. Some of it may be involved with the robot, some of it may not. For extended duration beyond the battery capacity, with power to be provided by shore power. So this covers the four quadrants of the two variables: electronics pack in the robot and not in the robot, and power delivered by the battery and by shore power. And then also when in normal operating conditions, the robot has a timeout after which it goes to sleep, and I want my electronics to power off as well, so that if the lawnmower finishes mowing and it goes and parks itself, and then after a while it times out and goes to sleep, my electronics should power off too, so it doesn't consume the battery. And when in normal operating configuration, I want to be able to press the robot on button and have my electronics power on and start up and start running the autonomy software. And then some other use cases like recharging and getting to minimum voltage and disconnecting the battery and using Wi-Fi. So those are the use cases that I intend to support. And so now this is the diving down into the power subsystem design, and I hope I don't get David's gong here, but I want to explain how this works. I think it's kind of clever, and then do a show and tell of the parts of it. And so I found everyone has 19-volt laptop chargers from various laptops they've owned. I had a 60-watt one, and I found this great little buck boost DC to DC converter that can be used for shore or charge. So it boosts the 19 volts up to 28.6 or 30 or thereabouts, and can provide shore or charge power. It's got all kinds of protection over temp, over power, over current. It's got a feature very helpful for charging lipos. It's got constant. It can operate in constant current mode. So if you hook it up to 30 volts and plug it into charge, where it's charging the lipos will suck it down to whatever their current voltage is, be it like 24 or 26, and it will current limit and deliver an amp or whatever you set the current limit to. Now here's where, and so there's a fuse coming out. The battery power. I don't have the BMS at present. That's on order. So at the moment, I've just got the batteries direct wired through the fuse to the ideal diode. And the ideal diode, its function is to, if I'm running on shore power, I just make sure that shore power is higher than battery voltage, and the robot will not draw any power out of the battery. So the battery charge will be conserved. However, and this feeds directly into MOA 24 volts, which is an unswitched supply. However, one of the benefits of the diode is that if the mower draws a lot of power, like I turn on the cutting blades, which will absolutely sink shore power, then the voltage droops on mower 24 volts. The ideal diode starts to forward conduct, and the batteries prop up the mower voltage during the high current period. So that's the function of the diode. It provides battery support and during heavy loads, and it allows it to run off battery when there's no shore power. But shore power can overdrive the voltage and save the batteries from being discharged during long development sessions when it's just sitting on the bench and I'm messing with software. The other element to this is the control of electronics to power off when the robot goes to sleep. So the way that works is mower power gets converted inside the mower to mower 5 volts to run various stuff inside the mower. And if the mower is powered on, such as I pressed the start button on the mower, then I have 5 volts in here, which forward biases the switching diode and turns on the solid state relay that passes 24 volts down into switch 24 volts and to the 5 volt DC to DC converter, which produces 5 volts for the RPI and sensors and such. Switch 24 volts currently just drives the Wi-Fi remote radio, the radio on the mower. But in order to support the use case of I pull the the box out of the mower, or the mower times out and I still want to keep on developing on it, there's an override switch that feeds 24 volts down through this switching diode to turn on the SSR. And then I can keep the switched power on and my electronics alive, despite the mower having timed out and gone to sleep. I think that's all I want to say about the wiring diagram. The schematic, does anyone have any questions on how the schematic works?
A little bit, Paul. Okay, so first, I guess the SSR has a voltage range of 5 volts to 24 volts.
Yes, exactly, and that's why I chose an SSR, is because they have, rather than a relay, is they have such wide switching voltages.
Mm-hmm. Now, what keeps, if you have voltage on the charge lead, that's on the anode of the ideal diode. If you don't have sure power, isn't that going to send voltage to your mower?
Yes, it will. And so when charging, the mower will be powered, but that's fine. I don't care about that. And I'm actually relying on the BMS to prevent overcharging of the battery array. So these BMSs have cell sensors. This will be a 7S battery. Currently, I have a 3S and a 4S in series, but that's what it'll be when the BMS arrives. And currently, I only have 5 amp hours of batteries installed. The original lead acid batteries were 18 amp hours, which means their usable power is 50% or 9 amp hours. So I will likely at some point increase the capacity, like double the battery capacity from what I have now. But this is like sufficient for software development and driving the mower around. Did that answer your question, Doug?
Well, I guess I'm not clear on what mower power is.
Mower 24 volts goes into the mower and enables the mower will turn on when it's first applied, but then the mower will go to sleep after a timeout.
Okay.
But 24 volts, so 24 volts is continuously applied, even when it's gone to sleep. And when the mower is in sleep mode, it only draws 5 milliamps. So if you work out the capacity of a 5 amp hour battery bank, that's good for several weeks of the mower being asleep. So I don't really need to worry about having the mower have unswitched power continually going out to the mower, because the mower will go to sleep and draw only a very minimal amount.
Mm-hmm. I guess I was saying, which one of these turns the blades?
Mower power will turn the blades and drive the wheels.
Oh.
So this mower power goes into the mower electronics. So the mower has its own circuit board, its own intelligence that controls blades and wheel speeds, and has a microprocessor on board that responds to serial commands. So maybe a system block diagram might be helpful here. So the RPi is currently wired to serial to mower, is in the demo I just gave. And so I send commands over serial to the mower to tell it to move the wheels. But the mower's microprocessor is the thing that actually PWMs the drive motors.
Mm-hmm. What if you want to turn it, let's say if you had this in store, I guess I'm a little concerned that the mowers would be, I mean, I know you have a control board, I understand it being turned off and everything, but if something were to go wrong, power is there to turn the blades. Do you know what I'm saying? It seems like there ought to be something that kind of like a fail-safe on the blade power, so that otherwise you have to either turn a switch to allow the power to the blades to actually be applied. You know, I keep thinking of the time that what's her name? Alyssa
Jason's
Pipe.
robot went wild.
Well, Alyssa Pipe, you know, almost cut off her finger because, you know, she was screwing around with a drone, and all of a sudden the blade started up, and you know, it was like, holy crap, you know.
Yeah, right. Alyssa and someone else was there, and the blade jumped at them.
Yeah.
I mean, that can certainly happen, and if you issue the wrong command to any robot when it's powered, then it can take off. There's some level of safety in the mower in that if you lift it up, there's an off switch on the mower, a sensor on the caster that will shut off the blades. And
So you already have a switch that shuts off the blades.
yeah, and there's also
Doug, would your concern be satisfied if he just had an actual physical switch that you have to turn,
I did. I mean,
that you
that
turn
would
on
do-
when you really want to use the blades?
right. Otherwise, if you're just sitting there, let's say you have this in your garage, like you showed us, and you got your battery pack turned on, and you know, some little kid, or I know you don't mind having a little kid, but let's say a little kid came over and, you know, started screwing with the robot. Since the power is always potentially there to start the blades, they could get started. You know, I don't know.
this is really
I
not,
understand.
yeah, it's really not different than your ordinary commercial lawn mowing robot, where if you press the start button, it goes. And to make the blades go, you have to do more than just press the start button. You've got to run the appropriate software and give just the right commands and so forth.
Well, no. Here, what I'm saying is, well, maybe I don't know. I'm just saying, Paul, it just kind of, I would like a hard switch on the mower blades. That's all, I guess what I'm saying.
It sounds like there already is at least one hard switch on the blades,
Yeah.
vis-a-vis the caster that switches them off when you pick it up.
Yes, and there's a second one also. There's a stop button on the mower that you can push. Let's see if I can point it out here. Let's see.
It seems like all these mechanisms kind of presume different failure modes or different scenarios, right?
Yeah.
So there's the active, oh shit, stop it. There's the, if it's not case on, it won't turn. So,
And so the red button on this controller power cycles the robot, so it will stop and need reinitialization before it could start the blades again. So there is actually a real, user accessible stop button that will shut down the mower and require software to be restarted to make the blades go again. Anything else on any other questions on the diagram, or else I'll move into show and tell.
Show and tell.
All right. So
diagram's cool though. I like that. That's clever.
Okay, so
I've got a question before show and tell.
Yeah.
Where did you get your electronics library for Draw.io?
it comes with it, I believe.
Oh, 'cause I looked under electrical and I'm not seeing like the diode symbols or anything like that.
They're there. Electrical diodes and electrical switches. I didn't import anything special.
Okay.
It's under electrical and logical gates, I bet.
Electrical and logical gates. Yeah, this is all just standard Draw.io.
Okay, that's it.
So this is the little buck boost converter that is just the cutest thing. It was like almost 16 bucks from Amazon, and just a little like inductor.
Paul, are you showing or? 'cause
Oh,
we're
yeah,
seeing-
we're not seeing anything.
We're seeing your face, but not the.
Oh. Hold on.
We got your face in the presentation still.
Are you looking at the presentation? I'm trying to do I'm presenting my desktop here.
Paul,
got-
what we're still seeing is the power subsystem graphic.
Oh. Okay. That's weird. Let me stop presenting and represent and see if that brings it back. Is this
Yeah, now we're seeing it.
okay?
There you go.
You see your hand on a mouse.
Yeah. Okay, so this is the front side of the buck boost converter, and it's a bit like setting a watch, and that's the only complaint I have about it is the user interface is pretty unintuitive, but you can dial the voltage up and down. You can press that and change the voltage setting, change the current limit setting. I've got it set to 1 amp current limit. It handles 35 watts without cooling, or 50 watts if you provide it with cooling. Here's the light that illuminates if it goes into constant current mode, and then you can press the on button to power it. Press the knob, and it powers it on or off. So and it's got protected against overcurrent, overpower, over temp, and I think I've exercised all of those things over the last few days.
Boy, look at that big choke.
Yeah. Anyway, it's a nifty little thing, and for 16 bucks, I reckon it's just a real bargain for buck boost. So I'm just converting it, just running it off of this little laptop supply. And in fact, when I started the blade, I did have the buck boost set to 3 amps, 30 volts, which is more than 60 watts. So the power supply, the laptop supply over current limited, which turned the buck boost converter off. Then it turned itself back on again, and it would sit there and cycle. So it was like pretty cool. So anyway, I think this is a neat little thing for this kind of application. Like I say, though, you do have to push lots of buttons and turn the knob a whole bunch to get anything to happen.
Paul, is that knob disabled while you're? What happens if while you're running around something bumps into that knob?
Well, so this is only for shore power, so it's not going to get bumped while owing to driving around. However, it could be bumped, but it's you have to turn it a real lot to change the voltage or current just a little bit. So it won't get changed unduly. So now the electronics box, so I'll unplug the serial cable from the controller, which is how the electronics box hooks to the robot, and you just lift this out, and it's still live. And as evidence of that, I'm going to shrink this down. And are you seeing my screen, my desktop now?
No. Well, we got your photo.
We see a white piece of paper with blue lines on it.
Do you not see my whole desktop?
We do see the whole desktop. There's a lot of
Okay.
things we see.
Yeah. So so another thing that I got out of Ubuntu, out of loading Ubuntu Mate, is VNC. So I showed before that I was SSH'd through my network into the robot, but into the API on the robot. But if there's stuff that you want to do graphically, then I loaded VNC, and Tiger VNC is capable of running while the API is in headless mode. So that was a nice thing to have. Okay, so now through the box, and let's see if I can just organize stuff to where I can show. Sorry, I'm probably making you guys seasick here. So this is the new electronics box that I've been building up over the last few days, and the back flap folds down. And so this is the serial cable that goes to the mower, and on the back flap is the RPi, and I'm going to put an ESP32 here. This is actually the old Arduino odometry thing that's going to get trashed. This is a Pico Station, a Ubiquity Pico Station with power coming from a PoE injector, passive PoE injector down here. So this is actually on a networking on a plate. So what I did was I built a plate here that holds the networking gear. There's a Wi-Fi adapter still to go on it, and maybe a USB hub, TBD. But it's got the Ubiquity Wi-Fi access point, which is wired through a small coax cable to this antenna. It's sort of buried in the corner. The white vertical shaft is the Wi-Fi antenna. You can see the LiPo batteries down the bottom, 7S. And then looking at the power electronics on the power wall, this is the ideal diode. This is a 50 amp ideal diode, costs like $12 or $10 from Amazon. These things are used in solar arrays, apparently. If you want to parallel some solar panels, you put an ideal diode in line with each of them. Then you parallel the outputs of the diodes so that panels that are outputting a lower voltage or don't have as much light falling on them don't get backdriven by panels that have more light falling on them, but instead they can allow their output voltage to rise to whatever it needs to feed whatever current they can feed. So the batteries, as I showed on the schematics, the battery power goes into one side of the ideal diode and then out the other side and off to the connectors, the robot power connectors here. So when you drop the battery box in, these metal connectors slide over some tabs and pass 24 volts into the robot. And then there's a terminal strip for ground, another terminal strip for +5 volts, and switch 24 here. And then down in there is the solid state relay and the 5 volt, 25 watt, 5 volt to DC to DC converter. So it can deliver 5 amps, which I've calculated should be enough to power everything that I plan on putting on the robot. so that's the show and tell. Does anyone have any questions? If not,
So I did notice in your diagram that you had that buck boost converter, and you said that it was choosing battery or shore power to be provided to the electronics. Is that
Yeah.
true?
yes.
I did not see the outputs showing that, but I'm not a great diagram reader.
Are you seeing the power subsystem
Yeah,
circuit diagram here?
right. I see from the buck boost converter, it says it's sending 30 volts to the shore charge.
Oh, okay. So shore/charge. So I've got a shore connector. I've only implemented the shore power connector at present,
Okay.
and that is actually this is the shore power connector here. So it wires down onto the switched relay onto the SSR, which I'm using as a terminal. So it wires down here onto the cathode of the ideal diode. I'm sorry, I said actually, and to the SSR switching terminal. I have not yet wired in the charge connector because I don't have a BMS yet, and so I'm not really ready to charge these batteries from the charge connector. They'll have to be charged from an external supply by removing them from the electronics box.
So
Did that answer your question?
at some point, the buck boost converter will be wired to that charge connector.
Correct.
Okay. That's what I didn't see, so I wasn't sure it was actually providing that function.
Right. I just haven't wired that in yet because I'm not ready to. Lacking a
Okay.
BMS, I'm not ready to
Keep
charge
us
it.
posted. I'm actually quite interested in that for one of my own projects. I'm trying to figure out, as a non-electronic person, how I'm going to pull that off. It looks like you're pulling it off.
Yeah, it actually I was actually pretty amazed. I've been able to pull this electronics box in and out of the robot and have the robot have the electronics stay alive. So I just carry the thing off and drop it right into the robot.
There's no prize for first mower that gets to running. Gold star for actually driving, but I want to see a mower actually mow. It looks like you got two contestants here.
Well, this is an intermediate stage, and so, but it was a significant point where enough electronics was implemented and nearly all of the power system is implemented that I thought it was worth sharing with you guys and sharing.
Well, Paul, couple of questions. That 7S LiPo pack, is that really going to replace two 18 amp hour 12 volt lead acid batteries?
This particular pack is only 5 amp hours, so it is only has half of the usable capacity of the 18 amp hour lead acid batteries. Remember that lead acid batteries are only supposed to be discharged to 50%, even deep discharge batteries, or else you drastically shorten their life.
They quit working. Yeah, we've seen that. Even those deep cycle marine batteries, they become flaky.
Yes, and so really the installed capacity as delivered on this mower was 9 amp hours of usable energy. I've got 5 installed now, so I really kind of need another 4 or 5 to get up to the originally installed capacity. So
wouldn't that just be another 7S pack in parallel?
yeah, or I'd probably you could do that, but yes, I could parallel them cell by cell, if they were suitably matched, or buy a complete 7S 10 amp hour battery, and I'm not sure which way I'll go yet.
And you have you have an external charger that works like a battery management system. It can see the individual cells and be sure that they all charge.
Yes,
Same one.
I have one for use until the BMS comes in.
I actually have a charger that for one of my helicopters that's designed to charge. It assumes you're using two packs, and it's actually designed to charge 2 packs at once and keep all of the cells in sync.
Nice. So anyway, that was
All right. Well, you've turned on a robot and made it move. So
Very cool.
here's your gold
Gold
star.
well, I didn't have. I'm afraid I couldn't move it autonomously, but
That
so I'm
doesn't
not
matter.
sure if
The gold star is if you can turn a robot on and it moves, because
Oh.
everybody in this group knows how hard it is to get to that stage.
Oh, yay! I get a gold star.
That's this is
Here you go.
non-trivial gold star with all those wires, Paul, and the smoke stayed in the box. That's a gold star right there.
Well, thank you for your attention, guys. And I didn't get the gong, so I feel good about that.
Well, cool. Paul, you're making tremendous progress.
Yeah.
That's great. That's just great. And the reason you're able to remove the whole electronics box and have it still be powered up is because when you remove it, you're removing the batteries as well. They go with the electronic box, not with the robot.
Exactly.
Well, that just worked out dandy, didn't it?
Yeah, and also I can connect and disconnect shore power at will, and the electronics box picks up. It just like picks up the voltage and then the ideal diode reverse biases. So I have and do plug and unplug with shore power, and the electronics all stays up. Yes, that's pretty
cool. I think that we're going to see more of that feature in next year's Club Robots, aren't we? Just plug them and unplug them and nothing happens. Okay, well, I was next in line with a question, but then for the queue, who can I add to the list after my question? Somebody
Well, I
has
can do
something
a
to
quick-
show or a question.
I can
I
do
ha-
it.
I have a-
would tell.
Okay, Doug D has a show and tell, and Doug P as well.
No, I just have a statement. I'm going to just say,
Okay. All right. Good. All right. So let me jump in. So I have a question that's loosely, well, it's a stretch to say it's related to robots, but it seems that I need to change the layout of my garage to lay things out again. And I'm wondering, who can recommend what's the best like 3D sketching software these days so I can get the dimensions figured out for what I need to do and what I can fit in there? I mean, is it Google Sketch or are there others? I haven't looked in several years, so I'm wondering what would be a good thing I could use.
I'm going to say Fusion 360, but that's probably overkill. SketchUp is probably what you're looking for
SketchUp
on that one, and that's probably well suited for what I know about SketchUp to do what you want to do. You're not looking for a watertight manifold or any of the other things, and you don't really care about a lot of other things. I'm sure I haven't looked at SketchUp for a long time, but I know that's one of the deals in the 3D printing world. Sorry, Murray, I mentioned it. In the 3D printing world, SketchUp, it's easy to make a non-watertight manifold, meaning your object is not complete. You could have planes that go like this, even though to your eye and how you can look at them, they're connected. They're really not. When you go to 3D print them, weird things happen. But SketchUp would do probably what you want to do. That'd be my recommendation, unless somebody else has a better one. It should be free, should be easy to pick up.
Yeah, that's
you know,
free,
that
easy
sort
to
of
pick
stuff.
up. It'd be nice if the same tool could let me do 2 or 3D floor planning, but then, after I figure it out, I could use it for 3D printing as well. So it'd be nice if it understood volumes, but I don't know if I want to take on Fusion.
I'm not saying it doesn't. There's plenty of people that use that to do their 3D modeling for printers and all that kind of stuff. It's just it's easy to get yourself in a way that makes your that might make your model non-printable. Where there's other things out there, like even as low end as bottom end as like Tinkercad, you won't get into those situations and cause yourself strife further on down the line.
So Harold just mentioned Tinkercad. I've been meaning for some time to learn a 3D modeling tool so that I could make 3D models, and so I learned Tinkercad over a few hours in the last week or so, and found it very easy to use. I had previously tried to learn SketchUp, and I just didn't find it intuitive. But Tinkercad they've got like a whole bunch of easy to follow tutorials, so that's another one you could consider.
Tinkercad is the gateway drug to Fusion 360, by the way. If you didn't know that, what you'll find is when you start running out of capabilities to do what you want to do, which you may never do that, depending on what you're doing in Tinkercad. The next step up from that is Fusion 360. Very similar, made by the same people. The interfaces are very similar as how they operate. Their coordinate system very similar as well. There are lots of similarities there.
Hey, Harold, I've played around with Fusion 360. What's your experience with Fusion 360? I mean, it's pretty amazing, but it is daunting.
It is amazing. I've been using on and off for 2 or 3 years. All the stuff that I do, every bit of the stuff that I design that I need to design, I use Fusion 360. I can't tell you that I'm an expert anyway, in shape or form. I can make a box. I can make some pretty neat looking things. I can cut some holes in a surface or two, and that sort of thing. I don't know, the Mr. Big Head stuff. I laid all that stuff out and a few other things. Not anywhere near an expert, but of the parts that I need to make that are functional type parts or cases or things that I'm doing, I can struggle with it a little bit, but I get it done.
Yeah, because I was starting to download some of the Go Builda parts and trying to compose them in Fusion 360 for the Mars rover, and I don't know, I might have got 6-8 hours in and I just gave up. It was just
that whole import process where you're taking in the Go Builda stuff. Did they give you STLs or they give you some kind of other file? That whole import into Fusion 360 with an STL, and then you got to import it, and then you turn off history, then you make it a model out of the body or something, and you can do all kinds of fun stuff with it. But there's a couple of things that's problem. I've had problems with that too.
Well, it wasn't so much problems. It's just that I looked forward into the future and realized I'd probably spend hundreds of hours modeling.
Yeah, what you need to get done.
And in reality, I just sort of played with it like Lego. It was just started building things. It was a lot easier because to try to model the thing and figure out where the angles were and all that was just, oh my God, I would have spent weeks, I think, trying to model the thing.
Yeah. I think you're going to have that. You might have some similar experience. I think SolidWorks has some low end product now. It's still pretty expensive unless you're in the first robotics or an educational thing to get an educational license, and then it's either pretty cheap or free. Fusion 360, if you're a hobbyist, they've reduced some feature set, but it's essentially free. You got to license it every year, but you license it as a hobbyist. Tinkercad's always free. That kind of stuff.
This isn't meant to be a criticism of Fusion 360. It's just the whole idea of 3D modeling a robot is just a lot of work.
Yeah, it is a lot of work. There's no doubt about it. There's a lot of work. And what I was going to mention, there's a couple other ones out there like FreeCAD and a few other ones out there that you may want to give a try and go. But I've just shied away from most of the non-pro level looking kind of tools, just because if I'm going to spend time learning something, I would like to learn something that I might be able to one day if I decide not to ever become a modeler, but at the very fact that I can talk to somebody that's using these type of tools and be able to have a good discussion with them without just being a complete idiot. Well, which is standard stuff. Was that my timer?
I'm still a big a big fan of Design Spark Mechanical. It's
Oh, is
me.
is that
I
the one,
love the way uh, I love the way you put models together with it. It's very intuitive to me, and I can. The problem I have with Fusion 360 in those is that I never really grasp exactly how the coordinate system works for me. Where with Design Spark Mechanical, it just seems the natural way to do that sort of stuff. And there's a few tricks that that overcome some of the limitations.
Yeah, I would second Design Spark Mechanical. That's the thing I've used to do all of my 3D models in to print.
Yeah, me too. I mean, it's very good, especially if you're going to be 3D printing the parts. One of the it turns out that there's if you don't mind skipping from program to program, you can overcome almost any restriction that's on the program. It turns out, I won't go into details, but if you look at the files that are in Design Spark Mechanical, there's actually space claim decoders, which is the main program anyway. I mean, it's the product of space claim. And so there are, once you get it into those file formats, there's a lot that you can do with it. And then there's if one of the limitations that a lot of people have against Design Spark Mechanical is that if you import a step file, it says you can't modify it. But what you do is you create an extra geometry, another solid, then you unlock it, and then it's complete, then you have complete control of the step file, just like you would anywhere. So that might not be obvious to a person using it the first time, but that's not a limitation of the program. And so it's, I just find it easy to it's the way my mind works, the coordinate system and designing stuff. So my general flow is, I look at the model and I say, okay, this is the way it's going to be. And I put it in 2D mode and trace out where all the parts are going to be. And then I turn it to 3D mode and then just do my extrusions and my moves and whatever I need to do. It just works real well. So, Paul, you might want to take a look at that. Steve Edwards, several years ago, did a training film on Design Spark Mechanical, which is on our website. Now that was a couple of versions back, but the program itself really hasn't changed. And so you could use that as he drew a model of a servo, an SG90, and so you get kind of the idea how to the process. Anyway,
cool. Thanks. This is very helpful. I think it's actually Design Spark Mechanical. I've used it before, but I couldn't remember the name. Yeah. And it's not on my new laptop. So
yeah. The other thing that does is kind of interesting. If you have an STL file, all right, and you want to convert it into, say, a step file, there's two ways you can do that. There's a real convoluted way in Fusion 360 that'll work. Okay.
It's convoluted.
Yeah, it's convoluted, but one of the nice features about it is you can do some adjustments of parts that have been faceted to make them a flat plane. The other way that's not so obvious is FreeCAD. You can go into FreeCAD, take your STL into FreeCAD, change it to the parts menu, and then once it goes on the parts menu, then I believe you turn it into a solid and don't care. You turn it into a mesh. You take the mesh. No, there's two steps. One is turning it into a body, I think, and then into a solid, and that works pretty well. So that's another way of getting, say, a step file from an STL file. So I actually keep FreeCAD on the computer, but its interface is bizarre to me, so I can't use it. But I use it to take ST files to step files. That's very easy. And if you're working in OpenSCAD, it has a lot of, there's a lot of features there that you can have. And that's really good if you're going to have something like you have 27 slots that you need to adjust them just a little bit depending on material variations. Then using a I can't think of the word. Anyway, OpenSCAD, that's where your 3D model is basically like a program. I can't think of the word. Programmatic.
Yeah. It's
Anyway,
the text-driven CAD.
They're
Yeah.
usually,
and that I've seen some wonderful models like for gears and stuff that are available out on Thingiverse, and you can create, like if almost any type of bevel or spur gear almost instantaneously.
I think you're thinking of parametric CAD.
Yeah, excuse me, thank you. That was the word I was trying to get out, but I couldn't quite get it out. And that there's sometimes when that is really, really useful. And it's the learning curve on that is not so bad because there's wonderful examples out on Thingiverse. I mean, you can look at somebody else's library and see how they did it. And then it's just like learning a language. Any computer language, you learn it by looking at other people's work. And you can do it fairly easily. But just for number one, I just go to Design Spark Mechanical. If I can do it in that, I do it in that. I find it really simple, really fast.
Ooh, what's Dave got?
Gears, Dave Ackley, done in which?
You're turned off, Dave.
Oh, he's muted.
You're muted.
There's mirroring on your webcam. Gears.
We can't hear you, Dave.
Yeah.
There you go.
The one on the left was the broken impeller on my lathe for the motor, and then the one on the right is the one done in 3D printed, and that was done in the Design Spark Mechanical.
Cool.
So, yeah, Design Spark Mechanical is what I've always used, and I've been done some pretty fancy stuff with that.
Yeah. If you're gonna, if I were talking to a young gentleman in college, I would tell him that he should go with 360 Fusion 360 because it's a more sellable skill. Okay, but for a hobbyist that's seeing the light at the end of the tunnel, I'd probably say I'd go with the Design Spark Mechanical.
I think Fusion 360, if I'm not wrong, that one, SolidWorks packages like that, I mean, they're able to do all kinds of stuff like physics modeling, properties, density of materials, and all kinds of finite element analysis and stress and loading and things, deformation.
The full-blown
See,
of Fusion.
It's very, very much so. It's just a
Yeah.
little crazy.
Yeah.
That full-blown version of Fusion for doing stuff will do all of that stuff. It's just it's a real kind of amazing. Like it'll do computer. I say computer design CAD. It'll do if you can give your if you have the right level of license, you can give it, hey, I've got so much tension here, I've got so much long here, give it your model. Now design me up the minimum amount of stuff I need for bracing and things on the model and go. And it's coming up with some pretty crazy things. For instance, bulkheads and aircraft. Their example was a bulkhead in an aircraft. They literally reduced the weight of that thing by like 75%. And because of their modeling and stuff, can guarantee it's still as strong as it was if it was just a full sheet of stuff going on there. Really cool stuff like that that's in there.
Yeah, the also thing, I think it's still available to the hobbyist. I haven't used it in a while. Is the you can get G-code paths for milling, which is really cool in Fusion 360. So I believe that's still available to the hobbyist. So let's say you had a CNC machine and you wanted to take your model and actually machine it, it'll generate the G-code for it. And that's kind of cool.
The other thing I was kind of looking for in a tool in general is, I think it's called parametric modeling. So like, let's say you have this bar and it's got a length, a width, and a height. And if I understood parametric, you could define one dimension as a function of another dimension. So that way you could
scaling.
Yeah, you could have a structure defined and then in one place say, well, L is going to be here, it's going to be this size, and then everything would just magically go to the right size.
Yeah, OpenSCAD is probably the best way a free way to do that.
Freeway.
Yeah, there is some, I'm sure we've all run into this situation where you created this big old model and all of a sudden you wanted to go from 3mm screws to number 6 screws. And you got all of these little slots all over the place.
Yeah.
And you want to change them and you don't want to go dook, 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 dook. You want them to all change at once. Parametric modeling is great for that. And I want to say 360 has that ability somewhere in it.
Yeah. What you want to do there is you want to set up a user parameter.
Yeah.
And you can define all these things like I've got a screw. This is my screw hole. And that's a number 6 or a 3mm or whatever it is you want to go do. And then everywhere you want to use that, you don't put it as a 3mm hole. You say that's a screw hole. And then at some point in the future, you go like, yeah, I've got 3mm, but I really want to use 4 because of whatever reason. You go into the user parameter and change it from a 3 to a 4, and it recalculates all of that stuff through historically in your model. It's pretty cool. And
the important thing is that they all grow from the centroid. That's what you want. You don't want something that's going to grow off one end. You really want it to grow off both ends, or you know what I'm saying. So the whole center is in the same place.
And then you can do wacky stuff with that same thing. So if I know what my material thickness is, and I want to do 2 times that thickness, or some kind of offset for what I'm doing I want my walls to be 2 times the material thickness, right? When I go set that, I set material thickness in my user parameter. Then when I go set the width of the wall when I'm drawing it out, I say wall material thickness times 2. And that's what I put in there. I put the formula in there for the width. And then so when I go back again, I change the wall width, everything else gets recalculated.
That's really useful. That's really useful for laser cutting. Because, on a laser cut, generally speaking, you have little slots and the next piece that goes in fits in the slot. Well, you want that slot, you don't want it to hang down below the material. You want it to be flush with the end of the material. So that depends on the thickness of the material. So having to be able to control that is a nice feature.
Saves a ton of rework.
Yeah.
A ton of rework.
Okay, cool. Yeah, many thanks. All right.
Yeah, Dave, I had a compressor that it had a squirrel cage blower on it to keep the compressor head cool. And I thought, oh, somebody must have printed this thing on Thingiverse because they're, you could get them in Amazon and a bunch of other places. And so I'm looking all through Thingiverse, no such luck. I had to just buy it. So.
Okay, cool. I think next we had Doug D with a question, and then after that, Doug P with a statement. So, Doug D.
So mine wasn't a question, it was a show.
Oh, I'm sorry, a demo. I've got all mixed up.
So this is a follow-up demo to my discussion earlier about converting RC cars to autonomous robots. And I bought my first little demo car, which supposedly I've been watching YouTube videos on how to do this. And you take your little ohm meter and you find out which pins fire off when you press things on your control. And that's supposed to be in here somewhere. And when you make that happen, that's cool. And this is my little demo. It costs like $9. I can break it or throw it away or make it work. And, it's wheel spin. I don't get a gold star for that because it's just an RC car, but you can maybe see the wheel spinning. But it works. And now the question is, can I find where the various controls make it work? Supposedly I can. So at some point in the next week or two, I'm actually going to stop doing some programming on my contract and do some robot stuff again. I'll try to get back to work here. But this is just the teaser to the real show and tell, because Santa Claus came through, and this is the that we were talking about last week. It's not as big as maybe a 4-year-old. It's 2 feet maybe. But
That was
say
I don't know, Doug.
It's
It's looking about as big as you, and you look like a really old 4-year-old. I'm just saying.
Right now, it's new in box, unopened, because I hadn't got to it. I'm not even going to open the box until I finish playing with this toy first. But have high hopes that that'll be my Robo Columbus base for my next robot. We'll see.
I've got similar ideas there, Doug. I got similar ideas. So I will be watching you. Got my eyes on you, man.
Okay, I'll be visible about while I'm doing it, because I've had a lot of trouble creating my own base with motors and all that kind of stuff. I get wired things wrong, and maybe I can just find the right wires on this thing and get back to the programming.
Well, so you haven't even opened your new box?
No, I'm a very patient person.
Oh, what discipline. I am so impressed by that kind of discipline, I must say.
Yeah, extraordinary restraint.
So that was all I had. I'm anxious to see what statement Doug Pardee has.
Okay, you guys ready for it?
Go.
Okay, I have received an email saying that we're excited to let you know that your order has been prepared and will be shipped out soon. And then when I hit the tracking button, it says your package is on its way to its destination and it's past the export scan in Hong Kong. So
I looked on mine. It said it was in Chicago.
Hey, yours is even further than mine now. Mine is on the way.
Hopefully it won't get lost between here and there.
Yeah. So anyway, I'm just saying it's probably in another week or so, we're going to have a bunch of us will be having open Oak D lights coming in.
More packages to set aside and show discipline for.
Yeah.
Must open package.
Yeah, well, hopefully Carl and I will get a shipping notification here in about another couple of weeks.
I'm hopeful. I'm with you.
Yeah, it's getting kind of nasty on the comment section there for the Pocket Pro thing.
It
So
should be. They're really. This is the Bluetooth oscilloscope voltmeter thing, and they're really playing the game on, collect the funds here and then sell it somewhere else, and then sooner or later catch up.
Yeah, it's just. I mean, we've all been very patient, and I am ready to wait a little bit long. However long it takes, because we may not even get it right. That's the Kickstarter.
Well, they'll deliver, I'm sure.
But I feel sure we'll get it. We waited this long, whining that you don't have it now, and you've waited already 2 years. What's a couple more weeks or another month or whatever it is, right? So I hate to say just suck it up, but you don't really have an option. I just think they've done a dirty pool for like you're in the 60s of a backer.
Yeah, I'm number 62, and I'm not a super early bird.
No, yeah, and because you ordered a duplicate, a dual up package, you're not considered a super early bird, so they send you later, even though you gave them more money. And so there's some games going on there that I don't really appreciate. Yeah, there's not a lot we can do about it though.
Well, I tell you what, if you read some of the I don't know if they were blog posts or just statements that came out of the OpenCV project, where they were trying to do it the right way, and there's a whole bunch of games when it comes to shipping product that different Kickstarter people use to get around, things like tariffs and taxes that are, they're really, really illegal, but
Well, when I bought my 3D printer from Shenzhen back, 5 years ago now, the box showed up and it said spare parts. That's what it was labeled on, spare parts. It wasn't a thing. It was just like, here's a bunch of junk in a box. We don't really know what it is. There you go.
Yeah.
It seemed like Lexanus, followed the rules. I mean, I thought it had to be valued like $800 or something to have those things apply.
Well, for the U.S., apparently it was no big deal, but for a lot of other places in the world, it was a big deal. So anyway, I'm glad it's Chicago. That's cool. I'm going to be sitting there waiting at the mailbox.
Could be another 2 weeks though. I mean, that's happened before. It goes into the U.S. mail black hole and then pops out the other end at some unexpected time. So
Well, this has all been the patience and self-discipline, the DPRGV here, which I don't really care for, I must say, although I'll have to remember this as an excuse. So instead of saying, oh, I haven't gotten around to it, that's why it's still in the package, I can say, well, I'm showing self-discipline.
That's exactly right.
Something else just popped up in my head, that a friend of one of the people that I helped them get the kit and build the 3D printer like I have back before, and they've done a lot of upgrades to it. It's now got them a Prusa, and they're looking to, I think, give their printer away. I believe he'd like to give it to somebody who would like use it and do stuff with it. And hopefully, I don't know, you want to give it to school, but I think he wants to donate it someplace. So any of ideas of that, I'll have to verify what his intention is. But he's looking at getting rid of a TiVo Tarantula, the old G that has all aluminum parts. He got rid of all the plastic, the acrylic parts on it, did all aluminum on it and that kind of thing. So if we know somebody, send me an email or send me a message, and I'll put you in contact with a guy, and you folks can hash it out on what that is. That's my only guarantee that I can put you in contact with a fellow.
I have an idea. Why don't we decide on, maybe David, you could issue blue stars for discipline.
Black.
Blue for holding your breath.
Black
No,
star.
we're already using black stars.
I thought Murray was talking blue as for another part of anatomy, but it's a whole nother story there, right? We'll just
blue round things. No.
Well, we might be able to do that one, but stars, I think we've run out of stars because we're using Unicode. You're using Unicode to do it. We got a black star and a gold star, and my understanding is that Paul gets a gold star for this meeting.
What's the black star?
Black star is if you make significant progress on a robot. May not necessarily show it to move, but you made. Otherwise, even if Paul had not run his robot on the ground, he would have still got a black star. Okay.
Black sounds bad, though. It sounds like you did something wrong.
Yeah, evil.
Well,
it's the only color we had.
Black, yeah. I thought there'd be all the colors in the world for stars, but turns out, no. Nope, there isn't. I could make it work by downloading something, a JPEG or something and inserting them, but I'm not going to do that. It's too much work.
Well, there was somebody a couple of months ago, was it John, who had built a shed so that he would have a workshop to have a place to build his robots. And that seemed like that. I think he got a star. I think he got a black star.
Yeah.
Mhm.
Well, I'm not sure. Like I say, we've only started this from, I think, December 7th. So,
And we're just
Yeah.
making it up.
yeah.
And the
So
whole
So
we-
we
what
don't
I'm
have a
saying
Smokey
is-
star for.
But
you know,
now
just
it
so people
goes in the
smoke
now it
of your
goes
robot.
in the meeting minutes.
it was all inspired by kindergarten.
And the
That's
Partially
why I wanted the
special
stars
Olympics,
to
maybe.
stick to your head, like your teacher put one on your forehead. There we go.
I remember
there
that.
you go. Yeah.
I don't think my grandkids ever got that done to them now. Probably can't touch the kid now, so you probably can't put it
Oh,
on his
yeah.
forehead. You can put it on the wall, but you can't put it on his head.
Wow.
Well, I was just looking in the Unicode set, and there's something called a sparkle, and there's also something called an 8-pointed star.
Yeah, but when you actually put it printed out, it looks a little wonky.
But what about glitter? It seems like there should be glitter for something.
Glitter.
That's a
Glitter.
different connotation entirely.
I was once in a Michael's one time, and somebody asked them, "Hey, do you guys have any glitter here?" I busted out laughing. I just
Say, no glitter here.
Aisle 4, third row back, 2 bins over. All right.
that was pretty rude of me to do that, but I couldn't contain myself at that point.
Yeah.
Ray, are you hearing that little bursts of white noise sound right now?
Yep.
Me too. It's
Okay.
like,
Okay.
If I can turn
All
off
right,
the
guys. Keep
microphone.
listening to it. See if
I
I'm
think
going to
it's
turn it
good.
off and see
Let's
if
see.
this.
Yeah.
Yep.
It's Doug's microphone is making me think my fan is going bad.
Is it still happening?
No, it's gone now with Doug's muted.
No, when he's muted, it doesn't do it.
I thought somebody in another dimension was trying to communicate with us in Morse code.
It's like Buckaroo Banzai in the fifth
Yeah,
dimension or whatever. it's called.
Oh, John Big Boutte. John Big
Yeah,
Boutte.
yeah.
Feels your pain, man.
Can you hear it now?
No?
No.
Okay. It was the fans on my Raspberry Pi.
Oh.
Okay.
So it was fan
Little
noise.
WD-40. It'll be
And
as
I've
good as
wondered
new.
when Ray
I
said it,
can't hear them, so I.
because I'm out here in my shop and I've got a big exhaust fan that I run sometimes. And it's real loud. There just seems to be a direct relationship between how much noise a fan makes and how much air it moves. I've got these ceiling fans. They kind of tick around real slowly, but they don't move very much air. So I'll just sit here in the hot. Don't put yourselves on.
You'll suffer for the group. Huh?
Have you seen those? Literally, this is the name of the company. Big ass fans. Have you
Oh,
guys
yeah.
seen those?
Mhm.
That's what happens when engineering gets applied to this ceiling fan business, when people were just making crap up before and thought it was a good idea, and somebody went and engineered it. And these guys, they're I went and looked at them a little bit, and they do some fantastic stuff. Of course, this was many years ago.
And they do have some big ass fans. You know?
That is very, very true.
I like the fans they have at the building test site. I think it's building material test site out on Lunar Road, not
Oh,
far
yeah.
from where Tanner's used to be.
Like
And
jet
our
engine
Attendees
fans.
building always have different glass panels and tiles and things, but they have 2 giant, it looks like radial engines from a World War II plane. They're on mobile stands. They wheel them over and aim them at the building and fire them up. Now that's moving air.
You know, that'd be worth the field trip if we knew when one of those tests were going to go off.
I know it.
See that, right?
And the crazy part is, if you just go like 1 or 2 lots away, I've seen people there that are practicing trapeze work, like for a circus.
Oh, wow.
Yeah, they're doing tightrope walking just a couple lots away from these fans, trying to knock a building down.
Well, guys, I'm going to have to leave.
All righty.
Let's see. I'm going to catch this.
Well, I'm looking around. I think pretty much everyone has had a chance. Is there anyone that hasn't jumped in yet that would like to?
No, I'm out of here too.
I haven't done any robotics work in weeks.
All righty. Well, it seems like
There you go.
the gold gong. Gentlemen,
That's
we'll
official.
catch you next year. Have a good time.
Happy New Year.
Think dream robots at least. Dream building robots. We'll get there.